Okay, I want to talk about reciprocal functions again and talk about how you can use the original graph of the function before you take the reciprocal of it to get some hints about what's going to happen with the graph of the reciprocal function. A few things to start with. We start out with this function f of x equals 1/2 x squared minus 2. That's this parabola that's graphed here. Now we want to look at what happens when you take g of x 1 over 1/2 x squared minus 2. You want to figure out what that graph is going to look like. One thing you know is that when the original function, the non-reciprocal function, is equal to 0, that is when the new function is going to have a denominator of 0, because that's the original function right there in the denominator. So when that equals 0, that is going to be undefined. The new function will be undefined because it'll be 1 over 0. So in the original function, when x is negative 2, you get 0. In the reciprocal function, when x is negative 2, you get undefined. And so that means whenever x equals negative 2, on the new function, you can't go there. You can't have an x of negative 2. So that whole line, x equals negative 2, is out of bounds. You can't touch it. All right? You also have, in the original function, 2, 0. So when x is 2 in the original function, you get 0 for y, which means x can't be 2 in the new function because you'll get 1 over 0. So that's not okay, and so you will have to have that other line that you can't touch, and those lines you can't touch but you approach are called asymptotes. All right, for this function, there's one more asymptote, and that is that when you have a reciprocal function like this, 1 over something that involves x, that can never be 0. You can never get 0. 1 over something will never be 0, because no matter what you put in the denominator, you'll never get 0 for that. So g of x can never equal 0, and therefore the x-axis is also out of bounds, because that is when y equals 0. And when I say the function g of x can't be 0, I mean y can't be 0. When I talk about the function, I'm talking about the y value of this function. So when I say something like, when does the function equal 0? The answer I'm looking for is what value of x makes the function 0. All right, so the function is y. So x-axis is out of bounds. Y cannot be 0 because you can't make it 0 no matter what you put in for x. Okay, so another thing you need to know about reciprocals. If you have a number x and x is between 0 and 1, then 1 over x is going to be bigger than x. All right, so if you have a number like 1/2 or 1/3 or 2/3 or anything between 0 and 1, the reciprocal of that number is actually bigger than the number itself. But if x is greater than 1, the reciprocal is less than x. So if you have a number like 50, 1 over 50 is less than 50. All right, so it's important to know these two facts. And it's also important to just know that when you have a reciprocal, the bigger the denominator gets, the smaller that fraction gets. So 1 over 1,000 is very small. That means the denominator is big, the fraction itself is small. And when the denominator gets tiny, like 1/1000th, and you take the reciprocal of it, that's big, 1,000. Okay? So those are important things to know about reciprocals and how they act. All right, so we have our asymptotes. We understand about reciprocals. So let's look and see what's going on here to the left of x equals negative 2. All right? What's happening to our function? Well, we know it's positive because we've already got negative 4 1/6, and that's positive. And we can't cross the x-axis, and we can't cross that asymptote x equals negative 2. So we're stuck. So as we're going from negative 2 down to the left on our x-axis, what is the original function doing? It's going up. It's getting bigger, which means that our new function has to be getting smaller. So it's coming from above, it's coming down, 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 and then it's going to try to get to that x-axis, but it can't do it. So it just keeps getting smaller and smaller toward the x-axis, but it can't touch it because it's just going to be 1 over a really big number, because as x gets more and more negative, x squared gets bigger and bigger. So it's just going to be 1 over some really big number. So that's what's happening to the left of x equals -2. To the right of x equals 2 now, the same kind of thing is happening. If you look as you go from positive 2 to infinity, what's happening to this old function? It's going up, it's getting bigger and bigger, which means, again, the reciprocal function will be getting smaller and smaller. So it's going to be decreasing down from over here, and then it's going to try to get to the x-axis, but it can't. And the bigger x gets, the bigger that denominator is getting, so it's just getting tinier and tinier, but never getting to 0. So now between -2 and 2 for x, what's happening to the original function? Well, as you go from -2 to 0 on the x-axis, this way, the original function is decreasing. It's coming down, 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 till you get to there. And so the reciprocal of that is going to be getting bigger. So it's coming from down here, and it's getting bigger, 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 up to there. And then, as you go from 0 to +2 on the x-axis, what is the original function doing? It's going up, 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 and increasing. So the reciprocal will be getting smaller and approaching that other asymptote. So there's a lot of thinking that goes on with these reciprocal functions and trying to understand exactly what the function's doing, but that's a very big part of calculus, and what we're trying to get to is the behavior of a function. What is the function doing in different places in the plane and for different values of x? How is the function behaving? Is it increasing, decreasing? Does it have any places that it can't go? So this whole idea of being able to look at an equation and figure out what the function's doing is a big part of what we're going to be doing in pre-calculus. So it isn't just a cut and dried process, but you can look at the original graph and get ideas about what's happening with the reciprocal function.